Hi, folks. Welcome back to 1.7, part 3. And so in this part, we're going to tackle the idea of finding inverse functions algebraically, all right? So we've talked about with numbers, we just switch the x and y, and for the graph, we reflect over that line y equals x. And when we're finding inverse functions algebraically, it really breaks down to a few steps, all right? So the first thing we're going to do is we are going to replace f of x with y. All right, so whatever equation we get, we're going to replace f of x with y. Now, if it already has y equals, then we're fine. We don't need to do that step, but sometimes we do. All right, then we're going to switch x and y in the equation. All right. Step 3, we're going to solve for the y that we just switched, okay? And then last, we're going to replace y with this inverse function notation, okay? So the switching the x's and y's, that goes back to that idea from the numbers. If we switch the x and y's in the coordinates, we're going to get the inverse function. Okay, solving for y just makes it a little bit nicer so that we can get a y equals at the end, and then we can say, oh, my inverse function equals this. Okay. All right, so let's start. Example 7, f of x equals x squared. So first step, I'm going to go ahead and switch or replace the f of x with a y. So y equals x squared. All right, now I'm going to switch the x and y. So I get x equals y squared. All right, step 3 says I need to solve for the new y. So I take the square root of both sides. I get y equals x, or y equals the square root of x. And then I'm just going to replace that y with inverse function equals square root of x. And this, my friends, is my inverse function, okay? Now, this says determine any restrictions on the domain. So the domain for this, because I have it under square root, the domain has to be from 0 to infinity. All right, so not so bad. We've seen that one both on the graph and with switching the numbers. Let's take a look at something a little bit more complicated, all right? So this one has f of x equals 5x cubed plus 1. And I thought it would be useful to think about this graph, which is the orange one here, okay? And see how we have this point 0, 1, and when we reflect it, we get 1, 0, all right? And same thing, 1, 6, we reflect it, we get 6, 1, all right? So this blue curve here is our inverse function, and we even have an answer here. All right, but what I want us to do is see if we can follow these 4 steps to get to the same answer, okay? All right, so first things first, y equals 5x cubed plus 1. All right, let's switch our x's and y's. So x equals 5y cubed plus 1. Now I'm going to isolate the y, or I'm going to solve for that. So first thing I'm going to do, I'm going to subtract 1 from both sides. Then I'm going to divide by 5. Okay. And now I've got y cubed, but I just want y. So I'm going to go ahead and take the cube root of both sides. All right. This is my almost answer. I just need to go ahead and write it with the correct notation. So inverse function is equal to the cube root of x minus 1 over 5, okay? And you might see this as x minus 1 over 5 to the 1/3 power later on in the class, okay? Now let's look at this domain though. according to the picture, the domain of this blue function is everything, all real numbers. But how could we tell from here? Okay, one good clue is we have not an even power, but an odd root. We have an odd root here. Okay, this odd root means that I can put any kind of number in here. I can have positive numbers, negative numbers, zero numbers, and that's fine. Okay, but also, even though I have a fraction, the variable is not in the bottom. So I don't have any special cases where I'm potentially dividing by zero and causing some problems, okay? And so that's why the domain for this one is going to be from negative infinity to positive infinity. All right, let's take a look at example 9. F of x equals x minus 2 squared minus 3, right? And so first things first, y equals x minus 2 squared minus 3. Now I'm going to switch the x and y. X equals y minus 2 squared minus 3. Now I got to solve for y, okay? So we're going to start by adding 3 to both sides. All right, now I want to get rid of the square, so I'm going to take the square root. And last but not least, I'm going to add 2 to both sides. But when I add 2 to both sides, does it go inside the square root or not? Okay, it turns out it doesn't, because I'm taking this whole thing and I'm adding 2. So I end up with square root of x plus 3 plus 2 equals y. And this, my friends, in proper notation, is the inverse function equals the square root of x plus 3 plus 2. And the domain for this, all right, let's think back to our domain rules. Ooh, I see a square root. I know that that thing inside the square root cannot be negative. So let's see, x plus 3 has to be greater than or equal to 0. Subtracting 3, I get x is greater than or equal to negative 3. That means my domain is including negative 3 all the way up. Okay, so this kind of problem is a nice combination of stuff we learned in this section, but also stuff that we learned in some previous sections. All right, example 10. Y equals x plus 3 over x minus 2. I'm going to go ahead and I'm going to switch the x's and y's. So x equals y plus 3 over y minus 2. Now you'll notice maybe that example 10 and 11 are pretty similar, right? Now this kind of question I think would be important for us to look at. It's weirdly an algebraic skill that comes up again in Calc 1. So being able to work with these fractions I think is an important piece, all right? So here we go. We're going to make things worse a little bit, but then they'll get better. All right, I'm going to multiply both sides by this denominator, y minus 2. So I'm going to get x times y minus 2 equals y plus 3. And then, weirdly enough, I'm going to distribute, okay? X, y minus 2x equals y plus 3. Now, I'm going to clump all of the terms that have an x in them, sorry, a y in them. So these two, they both have the y's on one side. And then everything that doesn't have the y's, I'm going to put on the other side. Okay. So in this case, I'm going to take this y, I'm going to subtract it to this side, and I'm going to take this 2x and I'm going to add it over here. So I get xy minus y equals 2x plus 3. Right? And doing that means I've got all of my orange terms on one side and all my green terms on the other. The reason why I want to do that is because now all the green terms have a y in them, which means I can factor out a y, and I get x minus 1 equals 2x plus 3. Okay. This is so clever algebraically, because now I want y by itself. I can just divide away this x minus 1. So y equals 2x plus 3 over x minus 1, right? And so this is definitely different than the other questions, because we have a fraction. We need to sort of cross multiply, distribute, and it gets kind of gross looking. But the distribution allows us to get all the terms that have y on one side, so that you can factor that out and then solve for that y, okay? So we want to write it in our correct notation. Inverse function of x equals 2x plus 3 over x minus 1, all right? And we also have to find our domain. Now, this one gets a little bit tricky as well, because we have to think about the domain of the original function and the domain of the inverse function, okay? So in our original function, let me zoom in here. I have a fraction. I cannot divide by 0. So what number makes that denominator equal to 0? Well, x is equal to 2, right? So I can't have 2 in the domain. But if I ask myself that same question here, I realize that x cannot be 1 either. So instead, I have to say from negative infinity to 1, in union with 1 to 2, in union with 2 to infinity. All right, so have to check both the inverse function and the original. All right. Now, if you want to try number 11 on your own, this is a good time to pause the video. But if you want to watch along, we'll go ahead and do that one right now. First thing, switch my f of x to y. Second thing, switch the x's and y's. X equals 3y minus 1 over y plus 5. Right? Multiply. X times y plus 5 equals 3y minus 1. Distribute. Xy plus 5x equals 3y minus 1. And we clump everything with the y's. And separately, we clump all the things that don't have y's. So xy minus 3y equals negative 5x minus 1. All right, the y's have been clumped. Y, parentheses, x minus 3, when I factor the y out of the left-hand side, equals negative 5x minus 1. And last step, divide by that x minus 3, so negative 5x minus 1 over x minus 3. All right, so definitely gets similar, but sometimes the numbers are different. So we just have to make sure we follow sort of those main steps, okay? We do want to go ahead and write our proper notation. Inverse function is now equal to negative 5x minus 1 over x minus 3. And our domain, let's check our original. So x can't be negative 5. And our inverse says x cannot be negative or cannot be positive 3. So my domain is from negative infinity to negative 5 in union with negative 5 to 3 in union with 3 to infinity. All right. Now, if we were in class doing this together, my assumption is that someone would ask me, well, hey, back at this step, what if I had moved the xy to the other side and I added 1 to the left-hand side? We could do that. All right, that might look something like this. 5x plus 1 equals 3y minus xy. Now, I can still clump my y's. 5x plus 1 equals y, parentheses 3 minus x. And I could still divide. Y equals 5x plus 1 over 3 minus x. And if I got this answer instead of this one, you might say, well, Judy, they look different. They look kind of similar, but they look different. Did I get the right answer? And my answer would be yes, you got the right answer. Okay, but if we notice, this is a 5x, this is a negative 5x. This is a plus 1, this is a negative 1. This is a positive 3, this is a negative 3, and this is a negative x and a positive x. It turns out that this, if I went ahead and I factored a negative 1 out of the top and the bottom, let's see what we get. Negative 5x minus 1 and x minus 3. And I know that if I have negative 1 times something and negative 1 times something, these actually reduce to 1. And look at what I get. Negative 5x minus 1 over x minus 3. All right, so we actually got the same answer, but we were just had sort of a negative 1 multiplied through the top and bottom in one version. Okay, they're really the same thing. It doesn't matter to me whether you get this one in the purple or you get this one in the blue. What does matter to me is that we know how to find the domain regardless of that. Okay. All right. Let's move on to our last two examples here. All right. So our f of x and g of x inverse functions. All right. And so we've got f of x equals 1 over x plus 2, and g of x equals 1 over x separately minus 2. And so our answer here says support your answer algebraically and using function composition. So I'm actually going to divide our page in half right now. We're going to go ahead and use algebra, and then we're going to go ahead and use composition. Okay, so two different ways to kind of answer the same question. So for the algebra, I'm just going to pick either f of x or g of x. Doesn't really matter which one. So let's choose f of x for this one. So f of x equals 1 over x plus 2. Now, algebra means I'm going to use the method I just used. So y equals 1 over x plus 2, which when we switch the x and y's is x equals 1 over y plus 2. All right, now I'm going to multiply both sides. X times y plus 2 equals 1. I could distribute here, or I could actually just say y plus 2 equals 1 over x, right? The only reason I distributed last time is because I was trying to get sort of the y's to be all on one side by itself. But in this case, I only have one y, so it doesn't make sense to distribute, okay? So y plus 2 equals 1 over x, last step, y equals 1 over x minus 2. In other words, the inverse function is 1 over x minus 2. This inverse function is what we have here. Right, so this is algebraically one way that we can show we have inverse function. Okay, now if you had done the same thing but started with g of x and went through this whole process, you would have found that what you got here matched your f of x. Okay. All right, so the other way that I want us to think about it is using composition. All right, so we're just going to take one of our functions and we're going to put it inside the other function. Okay, so in this case, I'm going to say let's take the g and we're going to put that inside of the f function. But again, it doesn't really matter which way you do it. So if I take the g function, g of x, and I put that into the f function, then what do I get? I get 1 over x minus 2 plus 2. So all of this right here, this 1 over x minus 2 is replacing that x, right? All right, let's see if we can simplify this. 1 over 1 minus x minus 2 plus 2 is 0. Okay, so really we have 1 over x. Now, I know some of us might get nervous when we're looking at fractions, all right? Now, for better or for worse, we have a lot of fractions coming up in this course and in calculus. And so it really is something I want us to lean into and just embrace the uncomfortableness, but see if we can really master it, okay? So 1 divided by 1 over x is really the same as saying 1 divided by 1 over x, right? Maybe let's move that up here. And we know from middle school that if we divide by a fraction, we really get 1 times the reciprocal, right? 1 over x, the reciprocal is x over 1. And when we multiply this out, we just get x. Okay, so if you remember way back in part 1 of the video, and I'm going to scroll up all the way back to there. Okay, we said that if we compose our two functions, right, whatever we put in should be what we get back out. Right? If we compose our two functions, whatever we put in is whatever we get out. We did this with numbers earlier, but now, now we're saying, hey, if you put x in, you should get x back out, all right? So I like this problem because we can show using algebra and compositions 2 ways to find whether something's an inverse function or not, okay? Now, if you want to practice 13 on your own, you can go ahead and do that. Pause the video here. Otherwise, we're going to explain this right now. All right, so we're going to try both methods again, algebra and composition. Now let's try and do it using the reverse order of the functions that we did in 12, all right? Because ultimately the order should not matter. In fact, it should work both ways, more specifically. So in the first one, we chose f of x, but this time I'm going to say let's choose g of x, okay? So for g of x equals the cube root of x plus 1, we would want to say that this is y equals the cube root of x plus 1. And we're going to go ahead and switch our x's and y's. X equals the cube root of y plus 1. Now, if we want to isolate the new y, the first thing we should do is subtract 1 from both sides. So x minus 1 equals the cube root of y. Now, to get rid of a cube root, I have to cube everything. So x minus 1 cubed equals y. Now, just a friendly reminder, this is not the same as x cubed minus 1. Okay, this is not the same thing as x cubed minus 1, because this is actually the same as x minus 1 times itself 3 times, right? So I would have to FOIL everything out. I can't just distribute it like that. Right? Let's see. Let's write this in the inverse function form. Inverse function of x equals x minus 1 cubed. And is that what we got here for f of x? Yes, it is indeed. So this is the same as this, which means that my g of x and f of x are inverse function. All right. Now let's try the compositions. All right. So last time we put the g inside of the f. This time, let's do the reverse. Let's put the f of x inside the g of x. And so notice that we're putting x in, which means at the end, we should end up with x. All right. In the g equation, instead of the cube root of x, I'm going to have the cube root of x minus 1 cubed plus 1. All right. So the reason why I'm doing that is because everywhere I see the x in this equation, I'm putting in the f of x equation, okay? And if you need to go back and review that, that should be in our section talking about compositions, okay? All right. Turns out a cube root and a cube, those undo each other. So I get x minus 1 plus 1. And we knew minus 1 plus 1 is 0. So I end up with x. Right? And that is exactly what I want to end up with. I put in x, I get out x. All right? All right, my friends, this is it for 1.7. In fact, this is it for chapter 1. So get started on that quiz number 1 for this week, as well as your My Open Math for 1.7. And I'll see you back here for chapter 3.